Okay, teammates. So today we are dividing whole numbers, mixed numbers, and fractions greater than 1 by non-unit fractions, and we are going to be justifying our answers and proving why our quotient is correct by drawing a tape diagram. So we are starting off with the standard algorithm and then drawing the tape diagram. To remind us that when we look at our first key point, it tells us that to divide by a non-unit fraction, we can multiply the dividend by the divisor's denominator and divide by the numerator. Luckily for us, we can think of this in the simple terms of keep, change, and flip. So when I say we are going to do the standard algorithm first, this is what I mean. So looking at this first expression, it says 5 divided by 5/6. So I'm going to think to myself, what is this question asking me to do? This expression is telling me that I am trying to find how many groups of 5/6 are in 5 wholes. So to find my quotient, I'm going to start by writing 5 in fraction form. So remember, a whole number written as a fraction is just over 1. So I have 5 over 1. That is me keeping that first fraction. Now I'm going to change my operation from division to its opposite, which is multiplication. And then I'm going to flip that second fraction. Remember our key vocab word, reciprocal. Reciprocal is the interchanging of the numerator and denominator. That is the way that we refer to the flip part of this. So we flip the second fraction. So now, when it comes to multiplying fractions, I just multiply straight across. However, some of you have already demonstrated your understanding of cross-simplifying or cross-canceling. So I see that 5 and 5 are diagonal from one another. So the greatest common factor of 5 and 5 is 5. So 5 divided by 5 is 1. 5 divided by 5 is 1. Multiplying straight across, I get 1 times 6 is 6. 1 times 1 is 1. Let's say you're like, Miss Bryce, I'm not positive how to cross simplify. We haven't had enough practice. Totally fine. We will practice more throughout this year. So let's back up. 5 times 6, just multiplying straight across, is 30. 1 times 5 multiplying straight across is 5. If I have the fraction greater than 1 of 30/5, I know that I can divide my numerator by my denominator and find that my quotient is the whole number 6. Okay, so either way we found our quotient of 6, and now I'm going to use a model to prove that my quotient is correct. So to save some room, I'm going to rewrite my quotient up here. So now I ask myself, how am I going to start this tape diagram? I need to represent the whole thing that I start with. So I am going to represent 5 wholes by drawing 5 whole tape diagrams. And actually, to save room, I'm going to draw them vertically. Miss Bryce is running out of room, and that's okay. As long as we understand these represent 5 wholes. This is 1, 2, 3, 4, 5. Okay, so now I am trying to find how many equal-sized groups of 5/6 are in these 5 wholes. Okay, so I'm going to label this as 5. Now, in order to find how many groups of 5/6, I need to separate all of my tape diagrams into 6. In order to do this, I'm going to draw 5 equally spaced lines in all of my boxes. Okay, so now I have 5 tape diagrams all split into groups of 6. So remember, one of these boxes is equivalent to 1/6. So now I'm looking for groups of 5/6. So I'm going to identify this in a slightly different way, because you might be thinking, how are we going to draw lines to have this make sense? So what I'm going to do, since we have the luxury of using technology right now, I am going to shade in with alternating colors groups of 5, 6. So I see 1, 2, 3, 4, 5. And then I see 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. Okay, so I use two different colors so we can see the separation of the groups. So I see that I have one group, a second group, a third group, a fourth group, a fifth group, and a sixth group. So this proves to me, using this tape diagram, that there are 6 groups of 5/6. That matches my quotient above, so I have proved that my answer, my quotient, is correct. Okay, teammates, looking at this second problem. It says, which equation accurately represents the model below? Explain how you know. Okay, so before I even look at my multiple choice answers, I want to evaluate this model a little bit. I want to see what I am starting with. What is the range of numbers that I am dealing with? I see that the whole number line goes all the way to 5, but I see that we are only working with 0 to 3. So I think to myself, okay, what is the whole thing that we're working with? It is 3. I see 1, 2, 3 intervals here. And then I need to think to myself, okay, what is the spacing? What is the fractional piece that is being represented? I see that if there are from 0 to 1, so if this represents 0 to 1, this represents 1 to 2, and this represents 2 to 3, I want to see how many pieces I split them into. I see 1, 2, 3, 4. So they're split into fourths. Okay, so this is just another way to look at the number line. So we have it split into fourths. Now I see that there is this circle around some of those pieces. I see that it is circling 1, 2, 3 of those fourths. So this would be the same as 1, 2, 3. Okay, so one of those groups is 3 fourths. So I asked myself, what could this be asking me? And then I'm going to use what it's asking me to write an expression. I know that if I'm writing a division expression, I always start off with the whole thing. What is the total that I'm eventually going to split up? I already identified that 3 is the whole thing that we're starting with. So it is going to be my dividend. 3 is my dividend. It's what I am starting with. I know that we are focused on division. I also notice that all of my answer choices are division. So I need to ask myself, what am I dividing by? What is my divisor? Okay, so I look at what the number line shows me. So at first glance, I see that there are 4 groups here. So this question could be asking, 3 divided by 4 gives me a quotient of what? Okay, so let's see, is that even an option here? I see 3 divided by 4 is choice D. And I look and see that the quotient is 4. Does that make sense? If I took 3 and split it into groups of 4, or split it into 4 groups, that my answer would be 4? No, that does not make sense. Okay, so D is not the right choice. Okay, so I have already committed that I am starting off with 3 as my whole, so I ask, what else can I get rid of? Choice B has 4 as the dividend, so I already know that that's not going to work. Okay, so now I'm going to ask myself, what could I also be asking based on this question? I'm going to refer back to the tape diagram model that we started to draw. If I have the range of 0 to 3, and we're talking about 1, 2, 3 tape diagrams here, and we know that we were looking at a group size of 3/4, what if I had my dividend of 3, and I was asking myself how many groups of 3/4 are in 3? So I could check 3 over 1, keep, change, flip. So I change it to multiplication, and then I flip the second fraction. Whoops, that's not my denominator, it's 3. Multiply straight across, 3 times 4 is 12, 1 times 3 is 3. That fraction greater than 1 becomes, when I divide my numerator of 12 by 3, 12 divided by 3 is 4. I can also check and see that, okay, here's another group of 3/4. So that's a second one, another group of 3/4, that's a third, and look at that, a fourth group of 3/4. Okay, so this problem wants to trick me. I need to be very careful that I pick the correct dividend of 3. All right, both choices give me 3. And then I am dividing by what? I asked myself, okay, how many groups of 3/4 are in 3? So the problem that we just evaluated is represented with choice C. Just so I feel like I can sleep tonight and it's not going to bug me, I'm going to double check my answer for A. Is this even a possibility? When in doubt, I'm going to use the algorithm keep, change, flip. So if I have 3 over 1 divided by 3 over 1, let's just see, 3 over 1 times 1 over 3 equals 3 over, wait a second, what do I know? Anything divided by itself is what? It is 1. So is A even an option? No. Okay, so throughout this process, we use multiple different ways, including a tape diagram and a standard algorithm, to prove that C is the correct choice, and that is what is being modeled here.